Hello, dignitaries and friends. The day of 2nd September is birth anniversary of Friedrich Wilhelm Ostwald. He received the Nobel Prize in Chemistry in the year 1909 for his scientific contributions to the science through catalysis, chemical equilibria, reaction velocities. He was a Baltic German chemist and philosopher. Next one. He was born on the day 2nd September in the year 1853. He developed his interest in science as a child and conducted experiments at his home, particularly related to the fireworks and photography. He is credited with being one of the founder of field of physical chemistry with Jacobus Hendrikus Fontoff, Walter Nernst and Svante Arrhenius. Next one. This is excellent opportunity for me to discuss on contribution of Ostwald to the science. In colorimetry, the Ostwald color system is color space that was invented by him. Associated with the color harmony manual, it comprises a set of paint chips representing the Ostwald color space. There are 4 different editions of the color harmony manual. Each manual is made up of charts, with each chart being a different color space. Next one. Ostwald also conducted significant research on dilution theory, leading to the law of dilution, which at time is referred to as Ostwald dilution law. This theory holds that the behavior of weak electrolytes follows the principle of mass action, being extensively dissociated at infinite dilution. This characteristic of weak electrolytes can be observed experimentally, such as electrochemical determinations. Next one. Through his research on rates of chemical reaction and velocities and his studies of acid and bases, Ostwald found that the concentration of acid or base in the solution of certain chemical reactants can have a strong influence of rate of chemical processes. He realized that this is manifestation of concept of chemical catalysis, first articulated by the Berzelius. Ostwald then articulated the idea that a catalyst is a substance that accelerates the rate of chemical reaction without being a part of either reactant or the products. Ostwald's advances in the understanding of chemical catalysis were widely applicable in biological processes such as enzymatic catalysis, also in many industrial processes. Platinum is one of the catalysts used in processes of production of nitric acid, that is Ostwald invented. Next one. Ostwald process is a chemical process used for making nitric acid. Ostwald developed the process and he patented it in the year 1902. The Ostwald process is a mainstay of modern chemical industry and it provides the main raw material for most of the common type of fertilizer production. In the first stage, ammonia is converted to the nitric acid. In the second stage, the nitric acid is oxidized by heating with oxygen in presence of platinum as a catalyst. In this second stage also, there is a yield of nitric acid, nitric oxide. This reaction is strongly exothermic, making it useful heat source once initiated. Initially, the nitric oxide is oxidized again to yield nitrogen dioxide. This gas is then readily absorbed by the water, yielding the desired concentration of the product. Here, the small portion of nitric acid is reducing back to the nitric oxide. This nitric oxide is recycled and nitric acid is concentrated to the required strength by the distillation. Next one. Ostwald ripening is phenomena observed in the solid solutions or liquid sols that describes the change of non-homogeneous structure over the time, that is to say, the small crystals or the sol particles dissolve and redeposit onto the larger crystals or sol particles. Dissolution of small crystals or the sol particles and redeposition of the dissolved species on the surface of larger crystals or sol particles was first described by Ostwald in the year 1896. For colloidal systems, Ostwald ripening is also found in water in oil emulsions, while flocculation is found in oil in water emulsions. Best example is cited here in this slide. Next one. In material science, Ostwald rule describes the formation of polymorphs. The rule states that usually the less stable polymorph crystallizes first. Ostwald rule is not a universal law but a common tendency observed in the nature. This can be explained on the basis of irreversible thermodynamics, structural relationships, or a combined consideration of statistical thermodynamics and structural variation with the temperature. Unstable polymorphs more closely resemble the state in solution and thus are kinetically advantaged. For example, out of hot water, metastable fibrous crystals of the benzamide appear first, only later to the spontaneous convert to more stable rhombic polymorphs. Next one. Ostwald Viscometer is working on the principle of Poisson's law. Accordingly, in case of laminar flow of the fluid, the flow rate of liquid can be denoted as ratio of pressure difference with respect to the viscous resistance. The value of viscous resistance varies directly with respect to the viscosity of the fluid and the length of the tube. Also, the viscous resistance value is inversely related to the fourth power of radius of the tube. Ostwald viscometer is also known as the capillary viscometer. It typically makes use of rate of flow of liquid through a capillary tube to determine the viscosity of the fluid. For this purpose, the fluids are typically made to flow through capillary tube between the two marked points, and the time taken by the fluid to flow between the 2 points marked on the glass tube is noted with the help of stopwatch. Next one. Ostwald-Folin Pipette is for liquid transfer. It is with graduation and 1 mark. It is suitable for scientific research, universities, healthcare, industrial and mining enterprises and other units of the laboratories as disposable utensils to transfer volume of the liquid. Next one. The Ostwald-Freundlich Equation governs the boundaries between the two phases. Specifically, it relates the surface tension of boundaries to the curvature, the ambient temperature and the vapor pressure or the chemical potential in the two phases. Ostwald-Freundlich equation for the droplet or particle with radius r is shown here in this slide. Next one. Liesegang rings are the phenomena seen in the many, if not most, chemical systems undergoing precipitation reaction under certain conditions of concentrations and in absence of convection. Rings are formed when weakly soluble salts are produced from reaction of two soluble substances, one of which is dissolved in a gel medium. The phenomenon is most commonly seen as rings in petri dish or bands in test tube. However, more complex patterns have been observed, such as dislocations of the ring structures in a petri dish, helices in Saturn rings in the test tube. Despite continuous investigations since rediscovery of the rings in the year 1896. The mechanism for the formation of Liesegang ring is still unclear. Several different theories have been proposed to explain formation of Liesegang rings. Wilhelm Ostwald in the year 1897 proposed a theory based on the idea that precipitate is not formed immediately upon the concentration of ion exceeding a solubility product, but a region of supersaturation occurs first. When the limit of stability of supersaturation is reached, the precipitate forms and a clear region forms ahead of the diffusion front because the precipitate that is below solubility limit diffuses into the precipitate. Next one. In continuum mechanics, a power law fluid or Ostwald-Dewey's relationship is a generalized Newtonian fluid, that is time independent non-Newtonian fluid, for which shear stress is given by consistency index into shear raised to n, where n is flow behavior of the index. According to the value of n, there are three different types of fluid as shown here in this table. Next one. Ostwald coefficient for the blood gas is solubility of inhaled anesthetic in the blood. According to the Henry's law, the ratio of concentration in the blood to the concentration in gas that is in contact with the blood, when the partial pressure in both the compartment is equal, is nearly constant at sufficiently low concentration. The partition coefficient is defined as this ratio and therefore has no units. The concentration of the anesthetic in the blood include the portion that is undissolved in the plasma and portion that is bound to the plasma proteins. Newer anesthetic are typically with smaller blood gas partition coefficients than the older ones. Blood gas partition coefficients of selected anesthetic products are listed here in this table. The potency of anesthetic product is associated with the lipid solubility, which is measured by its oil gas partition coefficients. Next one. In addition to his research in chemistry, Wilhelm Ostwald was productive in broad range of the fields. Ostwald was also engaged in the peace movement of Bertha von Suttner. Among his other interests, Ostwald was passionate amateur painter who made his own pigments. He left more than 1,000 paintings along with 3,000 pastels and the color studies. For Ostwald, science and arts are mutually supportive areas for the engagements. His career was adorned with remarkable performances like a Titan. Ostwald raised the global scientific culture. Next one. This is the list of few references. Next one. After the string of recent successes, journey of global science guided by Wilhelm Ostwald gains in maturity and stature apart from adding a new dimension to the capabilities of global science avenue. Let us pray for the salvation of the departed soul of this great scientist. Next one.